All right, let's start our discussion of chemistry by talking about classifications of matter. You may wonder first, what exactly is matter? You've probably heard that term, but may not know an exact definition of it. The definition of matter is simply anything that has mass and occupies space. So most of the things that we see and many things that we can't see have mass and occupy space and would be classified as matter. So table, people, chairs, food, drink, all of those are examples of matter. Or air, something you can't necessarily see, but it certainly has mass and does occupy a space. That would be classified as matter. Something like light that does not have mass or occupy space would not be classified as matter. Now within matter itself, we can classify matter in a couple different ways. We can classify it first just based off of its state. And there are three main states of matter. There are a couple others, but three primary states, and those are gas, liquid, and solid. An example shown here using water kind of illustrates those three. So if you have an ocean that's got icebergs, certainly we have the liquid water of the ocean, or you can have frozen water in its solid form that forms the icebergs. But then in the air above, there's also water vapor. And you may think about clouds as being water vapor, or you've probably certainly seen water vapor if there's been a hot shower or something. You know, you've seen water kind of in the air. That's an example of water vapor. And there we have an example of the three primary states of matter: gas, liquid, and solid. You can also classify matter based off of its composition. So what is the composition at a fundamental level? So at the very, very fundamental or lowest level, we can look at atoms of an element, bare atoms of an element, or we could have those atoms combined together to form what's known as a molecule. That's when more than one atom is joined together. But if those two or more atoms could be of the same element, so we can classify it based off of that. And in this case, it's just one kind of an element. Or we could have molecules that have multiple elements, and those are referred to as compounds. Additionally, we could have, so just to clarify here, compounds have at least two different types of atoms, whereas in the previous case, you can have molecules that are just molecules of a single element. And so we're classifying it based off of how many atoms, and primarily the types of atoms that are present, whether it's just atoms, whether it's molecules that are composed of the same type of atom, whether it's molecules composed of different types of atoms, or we have mixtures where you now have maybe elements or compounds and maybe molecules of just a single element. So we can classify matter as being one of two things. It can be a pure substance, or it can be a mixture. A pure substance would be one of the three examples here on the left side. So just atoms, molecules of just one element, or molecules of multiple elements, otherwise known as compounds. Those would be pure substances, versus a mixture would be essentially multiple of different types. It could be multiple of different types of molecules, just not the same type of molecule. And we'll go into this in a little bit more detail. Now, talking about elements, what exactly are elements? Well, you'll find them commonly on the periodic table, and we'll talk in more detail about what exactly an element is. But here are some examples that you'll find: carbon, fluorine, hydrogen. In many cases on the periodic table, the elemental symbol matches just the first letter or first couple letters from the element itself, the elemental name. Now, in some cases, like sodium or silver, that is not the case, and that's because the name or the letters come from the Latin name rather than the English name, as many of these were discovered in ancient times. Now, those would be elements, which would be a pure substance. But then also let's talk in more detail about a mixture. What exactly is a mixture and what types of mixtures there are? So a mixture is defined as matter that contains multiple different substances. Each of those substances retain their own chemical identity, but the matter itself is composed of multiple different substances. So here's two examples. We can have a homogeneous mixture, and this is where we have uniform distribution. So if you take this compound, which is copper sulfate, and dissolve it into water, you will get a uniform distribution of the copper sulfate in water. And so at any case, your mixture is composed of water molecules and copper sulfate molecules, or as we'll talk about later, copper ions and sulfate ions, but we'll talk about that later. For this case, it's just water and copper sulfate, so we have two unique things, but it's completely evenly distributed. If you took a sample of this mixture from the top, it would have the same composition as if you took it from the bottom or from the middle. The alternative is a heterogeneous mixture. This is where we have a non-uniform distribution. So you look at this piece of granite here, and if you look closely, if you were to chop off the corner, you would have a different appearance than if you were to chop off maybe farther on the side. That would look differently depending on where you sampled from. And that's the fundamental difference between homogeneous mixtures and heterogeneous mixtures. Is in a homogeneous mixture, it doesn't matter where you sample. In a heterogeneous, or the size of your sample. In a heterogeneous mixture, it does matter, and that you're going to have different compositions depending on where you sample and how much you sample. A nice flow chart that is designed to help us classify matter based off of composition is shown here. So if we just start with some sample of matter and we're like, I'm not really sure how to classify it. I'm not exactly sure whether it's a pure substance or a heterogeneous mixture. How do we go through this? Well, first we look at the matter and we say, is it uniform throughout? If the answer to that is no, then it can't be a pure substance. And it can't be just a compound or a single element. And so it must be a heterogeneous mixture. If it is uniform throughout, it could still be a mixture. We just know that it's homogeneous. It may be a mixture or it may not, but that's where we come and say, okay, within that sample, say we take a sample, does it have variable composition? That means if I look at all of the components, are all of the components in that sample, are they all identical? Or are there some that are different, even if they're evenly distributed? If there are some that are different, that would be variable composition, and I would have a homogeneous mixture. And the homogeneous mixtures are often referred to as solutions because most homogeneous mixtures are in liquid solutions, but you can have solid or gaseous solutions. So we won't use that term a lot to refer to gas or solids, but technically any homogeneous mixture is referred to as a solution. Now, if the composition is identical throughout, then we know that we have a pure substance. And we can break that down even more by saying, okay, does it contain more than one kind of atom? If it does, then that's going to be a compound. If it doesn't, then it's going to be an element. Let's go through a couple examples real quickly. So if we take, for example, filtered ocean water, and I simply say this because there are sometimes particles or seaweed, we filtered it first so we got out that. So you just have a sample of ocean water. We go through, first we'd say, is it uniform throughout? Well, because we filtered it, we can say, yes, it is uniform throughout. So it's not a heterogeneous mixture. So it would be homogeneous. But then the question is, does it have variable composition? Well, if we look very closely and with different tools, if you evaporated off the water of ocean water, we would be left with a bunch of salt. So it must have that there is clearly a variable composition there because we've got water molecules and we have also sea salt. And so yes, this would have variable composition and would be a homogeneous mixture. Another example would be sand. Say we took a scoop of sand from the sand at the ocean from the beach. First question, is it uniform throughout? Well, if we take our magnifying glass and look at it, it's not uniform throughout. Many of the grains of sand are different sizes, different colors, different shape. If I take one small sample of sand from one part of my sample and look at those individual grains of sand versus a different part of the sample, they're not going to match up. And so I would say that sand is a heterogeneous mixture.